Hi, good morning to all. I am Nandini from Knowledge Institute of Technology, Salem. Now we see the topic matrices. The definition of matrix is nothing but a rectangular box that containing m rows and n columns. It is simply as m cross n matrix. The below is an example of matrix. Square matrix. A square matrix is nothing but a number of rows and columns are equal are known as square matrix. This is an example of square matrix. Next, diagonal matrix. In square matrix, all elements are 0 except leading diagonal elements. This is the example of diagonal matrix. Lower triangular matrix. In square matrix, the elements above the leading diagonal elements are 0 is known as the lower triangular matrix. This is an example of lower triangular matrix. Next, transpose of matrix. The matrix A interchanging its rows and columns is called the transpose of A. It is simply denoted as A dash or A transpose. This is an example of matrix and its transpose. Inverse of matrix. It is simply denoted as A inverse. A inverse equal to 1 by mod A into HA. Also it's shown that A into A inverse equal to A inverse into A is equal to identity. A characteristic equation. The characteristic equation is nothing but mod A minus lambda I is equal to 0 is the characteristic equation of A. So the roots of characteristic equation as known as eigenvalue of matrix A. Now we see the property of matrices. First property, a square matrix A and its transpose A transpose have the same eigenvalues. Proof. It consider A be a square matrix of order A, order n. The characteristic equation is mod A minus lambda I equal to 0. Let us consider this equation as equation number 1, which is same as A transpose. This equation considered as equation 2. Since the determinant value is alternated by the interchanging of rows and columns, we get mod A is equal to mod A transpose. Applying this result, we get equation 1 and 2 are identical. Hence, the eigenvalues of A and A transpose are same. Now we see second property. The characteristic roots of the triangular matrix are just the diagonal elements of matrix. Proof. Let us consider a lower triangular matrix is A. We know the characteristic equation of A is mod A minus lambda I is equal to 0. Here I is identity matrix. We have this equation. Simplifying this equation, we have 3 eigenvalues because our matrix is 3 cross 3 matrix. The eigenvalues is A11, A22 and A33. These elements is diagonal elements of our matrix. So hence the eigenvalues of a triangular matrix are just the diagonal elements of the matrix. Next we see Cayley-Hamilton theorem. It means every square matrix satisfies its own characteristic equation. We see the one example of Cayley-Hamilton theorem. Using Cayley-Hamilton theorem, find A inverse when A is a given matrix. Solution. We know the characteristic equation of A is mod A minus lambda I equal to 0. Which is nothing but lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Here S1 is equal to sum of main diagonal elements. In our matrix we have S1 is equal to 3 and S2 is equal to sum of the minus of the main diagonal elements. In our matrix we have S2 is equal to minus 1. Also S3 is equal to determinant of A. So we have S3 is equal to minus 1. Applying this S1, S2 and S3 value in our characteristic equation, we get lambda cube minus 3 lambda square minus lambda plus 9 equal to 0. So by Cayley-Hamilton theorem, replacing lambda by capital A, we have lambda cube minus 3a square minus a plus 9i is equal to 0. In this equation, we have A inverse is equal to this equation. It is written as equation number 1. So we know that matrix capital A. So we find A square, 3A and identity matrix. Applying this value in equation 1. So we get A inverse. A inverse is equal to minus 1 by 9 into 0 minus 3 minus 3 minus 3 minus 2 7 minus 3 1 1. This is our solution of example. So in few seconds we see matrix and its few types, and also we see property of matrices and also see Cayley-Hamilton theorem with one example. I hope it is clear to you all. Thank you.